So today we're going to review some discussion with slope, and then we're going to expand on that a little bit as it applies to geometry. So slope, if you remember, is thinking about how steep a line is. You can have a line that does not have very much steepness. It doesn't rise a lot for however much it runs. Or you can have it more steep where it rises a lot and it doesn't run as much. Think about that you run horizontally. You can have positive slope, you can have negative slope, you can have zero slope, and you can have undefined slope. This is zero and this is undefined. Okay, slope is, our formula for that is y2 minus y1 over x2 minus x1. And where you're given 2 points, you can calculate the slope between them. You can also count the slope straight off of a graph if you have it on a graph. So the application for geometry is that parallel lines have the same slope. That makes sense. Parallel lines, if you remember, parallel lines means that they are coplanar lines that never intersect. So they run side by side, and they have the same slope because they rise and run at the same rate, rise and run. And so they have the exact same slopes. Perpendicular lines, this is the symbol for perpendicular. Remember that perpendicular lines are lines that intersect at right angles, which is a 90-degree angle. And it is typically shown in a picture by that right angle. Okay, I have in the box in the corner. Perpendicular lines have opposite, meaning if it was positive, it becomes negative, and if it was negative, it becomes positive. And then reciprocal slopes. Reciprocal means you flip the fraction over. Okay, so you're going to flip the fraction over. So let's look at just some basic problems with this. We have a line, CD. It has a slope of 2/3. So what that means is this. We have a line, CD, and it has a slope of up 2 over 3. Up 2 over 3. So the parallel line, well, if I draw a line that is parallel to that line, it will look like that, and it will also rise 2 and run 3, okay, because it's parallel. So it has to go at the same rate. So it has a slope also of 2/3. The slope of the perpendicular line, so I want my line to be perpendicular to this line. Well, if I just kind of eyeball perpendicular, remember perpendicular means it has a right angle. It's going to be, notice that it goes in the opposite direction. This green line went up and to the right. It was positive. Okay, now this is going to go down and to the left. It's negative. Okay, and it has it does the slope backwards. Instead of rising 2 and running 3, it rises 3 and runs 2 in the opposite direction. So the perpendicular slope, it has an opposite sign. It was positive, so now it's negative. And that you can see that's evidenced by the negative slope. And then the fraction flips over. The 2 over 3 becomes 3 over 2, which is the reciprocal. Opposite reciprocals when they are perpendicular. So let's look at another one. We have line CD. It has a slope of -5. Remember, slope is rise over run. How much does it change vertically divided by how much it changes horizontally? So we need this to look like a fraction, okay, just to be able to figure out what everything is. It has a slope, and it's a negative slope, and it's pretty steep. So that means it rises 5 and runs 1, or you could also say it goes down 5 and runs 1. So you can look at it either way. Either way, you're going to end up with that negative slope. So if I want to draw a line that is parallel to that, it is going to do exactly the same. It's going to go down 5 and over 1. So it's going to maintain the same slope. Now when we report slope as an answer, we always refer to it as a simplified fraction. So we would never put -5 over 1 as an answer. We would always want to simplify that to -5. Now if I want to be perpendicular to that, then it's going to look something like this, right? We have that right angle right there, and it's going to do the opposite. Notice now it's positive. It's going in the up and to the right direction, and it's going to rise 1 and run 5. Okay, so it has a slope of 1 over 5. Opposite, this was negative, now it's positive. Reciprocal, you flip that 5 over 1 over and it becomes 1 over 5. Think about it like this. I took that green line here and I flipped it over. When you flip it over, that's your reminder that you're flipping over that fraction. You're changing the sign because it went from negative to positive, and then you're flipping that fraction over. So let's get some practice with this. I want to check to see whether the lines that go through these 2 points and these 2 points, whether this line and this line are parallel, which means they have the same slopes, perpendicular, which means they have opposite reciprocal slopes, and neither. Okay, so let's check. When you check, you're going to calculate the slope just like we always do. So the slope of line 1, I'm going to put a little subscript 1 like its last name, is y2 minus y1. Be careful with your signs. y2 minus y1 over x2 minus x1. x2 minus negative 3x1. Okay, that minus comes standard with the problem, don't forget. Then simplify it. Negative 2 minus 1 equals negative 3. Negative 7 minus a negative 3 minus a negative becomes plus. So negative 7 plus 3 is negative 4. Always simplify your fractions when you get to the end. Just double check. That negative over negative becomes a positive, so that simplifies to be 3 over 4. Let's check line 2 and see what it is, because if we're comparing the two lines, we need to know the slope of both lines. So now we want to find our slope, so we do y2 minus y1 over x2 minus x1. Be sure that you go in the same order. It doesn't matter if you do negative 1 minus 5, but if you do, you have to do 2 minus 10. Once you pick a direction, when you're calculating the slope, you have to stay in that same order. So 5 minus a negative 1, that changes to be plus a positive, so that would be 6 over 10 minus 2 is 8. Now, when you look at first at those, they don't look like they're the same, but always reduce your fractions. 6 over 8 reduces. You can divide by 2 and divide by 2, and you get 3 over 4. So once you get everything simplified, notice that this slope is 3/4, this slope is 3/4. They have the same slope, which means that these lines are parallel. That's the symbol for parallel. They are parallel to each other. Okay, let's check this other one. We have our slope. We want to check to see what our slope is. So the slope of line 1 is 4 minus 0 over 7 minus 1. 4 minus 0 is 4. 7 minus 1 is 6. And then that reduces. We always reduce that down. That will reduce to 2 over 3. And then line 2, we have 8 minus 1 over 9 minus 5. That would give you 7 over 4. So you can tell right off that doesn't have to be reduced, so you can instantly tell that those two are not the same. And so these are neither. They're not parallel or perpendicular. They just intersect. Now, I want to make one note here. Be very careful. What if I had a slope of one line that had a slope of 2/3, and I had a slope of the second line that had a slope of negative 2/3? The tendency is to say, oh, those are close to being the same, so they must be parallel. They have to be the same. The sign has to be the same, and the fraction has to be the same. They can't be close. They have to be exact. So these are not exact. So in this case, this is a different problem, but in this case, they would be neither. Okay? The same thing if I had the slope of one line was, say, 5 over 2, and the slope of the second line was 2 over 5. Again, yes, those are reciprocals, but they're not opposites. They have to be opposite and reciprocal. They have to meet both requirements. So these would also be neither. So I just want to call that to your attention so that you're careful when you are doing your homework with. Okay, so let's get some practice with graphing. Remember that when you are graphing a line, it is easiest to graph it in y equals mx plus b form. That is your slope-intercept form, y equals mx plus b. If it is not already solved for y, then you'll need to do that. So the slope is the number that comes before the x. It does not include the x. Okay, a lot of people, I'll say, what's the slope? And they'll say, for instance, on this one, they'll say, what's the slope? And they'll say negative 2x. That's not it. It's y equals mx plus b. The m is negative 2. Okay, the m is negative 2. So the slope in this case is negative 2, and the y-intercept is 4. Once you have those two pieces, you can go over here and graph the equation. You always start here at the y-intercept. You want to know where it's going to cross. So the b is the y-intercept, so you count 1, 2, 3, 4 on the y-axis. So that's 4, and then we're going to have a slope of negative 2. A slope of negative 2, remember we need a rise and a run. Don't forget, you can't just go negative 2. You have to do rise and run. So we are going to rise negative 2, which would be going down, 1, 2, and then we're going to go to the right, 1. You could also go up 2 and to the left, but you want a negative slope. And so then you're going to connect those dots. You're going to draw in a line. You have to have 2 points to make a line. We learned that in the last unit. And you draw in that line. And you put in the arrows to reflect that it continues forever. And we would label that line L. So we just put a little cursive L there at the bottom. Okay, so for number 6, notice that this is not solved for y. Now you can use intercepts to graph. It wouldn't work very as easily because the 4 doesn't go into 10. So we're going to solve this for y equals. So we're going to move this 4x over. The 4x can't combine with the 10, so we have 5y is equal to negative 4x minus 10. I put the x first. It can go at the end, but then it doesn't look like y equals mx plus b, and I want it to look like that. So then we divide by 5 all the way through, and then simplify your answer. Y equals negative 4/5 x minus 2. You can't simplify that 4/5. It doesn't reduce at all. So now we graph it. We start here. Here's our y-intercept. Our y-intercept is at negative 2, so we go over here and we put a dot at negative 2. Now we need another dot, and we need to know where to go. So this is what tells us it's a negative slope. So you have to go in a positive and a negative direction. So I'm going to go down 4, 1, 2, 3, 4, and to the right 5, 1, 2, 3, 4, 5. You can do a quick check and make sure that it's going to slope in the right direction, because we know that it has to be down and to the right for it to be a negative slope. We connect our dots, draw in our arrows to show that it's going to go on forever, and then we can do a quick label and call it line M. Okay, so right now we're just practicing to see how they're gonna how we're gonna graph. Because when we start writing equations, what I want to show you is how you can use a graph to get the equation. We can use the equation to get the graph, but you can also use the graph to get the equation, and I want to show you both directions how to do that. So what if I want to graph line N that passes through 5, negative 6, and has a slope of 5? Well, here's what we can do. We can start our graph right here. You have to have 2 points, so that's our starting point. 5, so 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, 6. They just all happen to hit in the same place, and has a slope of 5. Remember, slope of 5 means you have to have a rise over run, so we need to make that into a fraction by putting it over 1. So from here I would go up 1, 2, 3, 4, 5, and then over 1. Put another dot, and there are your 2 points that you can go to connect. It takes 2 points to make a line, so we need those 2 points. Okay, and that was to be called line N. So you'll just put that little cursive N on one end of your line. So you can start at your y-intercept, or you can start at a point when you're graphing a line. It doesn't matter. On this one I didn't have the equation. On the other ones I had the equation. Now, what if I want line T to be perpendicular to line N, and I want it to pass through 2, 4? Okay, what if I want line T to be perpendicular to line N? Well, let's go back. Line N had a slope of 5. Okay, so line N had a slope of 5/1. So think about what it was to be perpendicular. So my new line, line T, it has to have the opposite reciprocal slope. So opposite means this is positive, so my slope's going to be negative. And then reciprocal means you're going to flip this fraction over, so 5/1 becomes 1/5. It doesn't matter if the negative is in the top, in the middle, or in the bottom. It doesn't matter. It will all take care of itself. So now we know what our slope needs to be, and we're going to put our point. So this is our starting point. So we go over here to 2, 1, 2, 3, 4. That's where we're going to start this line. But now we're going to do it with a different slope, -1/5. So I'm going to go down 1 and then over 1, 2, 3, 4, 5. And I'm going to put a dot. There's my 2 points that I need to make the line. I'm going to connect the dots and draw them in. Put my arrows on there and label it with a T because it's line T. And I want you to look at it. Look right there. Okay, look at that little angle right there. I said I wanted my lines to be perpendicular. Perpendicular means that they are at right angles. Doesn't it appear that those angles are right angles? We know that they are because we used the math to make sure that we got the angles and to get the lines to have the relationship we wanted them to have. Okay, so then the last one, I want to graph line R so that it is parallel to line N, but it's going to pass through -5, -5. Okay, so I want to be parallel to N. N was right here. Remember that line N had a slope of 5. So it was 5/1. That's my rise over run. If I'm going to be parallel, then my line R needs to have the exact same slope. It needs to do the same thing. It needs to copycat. Okay, so it's going to have a slope of 5/1. It's going to start through -5, -5. So it'll be 1, 2, 3, 4, 5, and then -1, 2, 3, 4, 5. So you put your point, and now that's our starting point. We always have to have a starting point, and then we need to know where to go from there. We're going to go up 5/1, so up 5/1. There is our second point, and we draw it in. Missed one of the dots, but it's pretty close. But you can see, look at those two lines. That's line N, and that's line R, and they are indeed parallel to each other. So parallel lines have the same slopes. Perpendicular lines, these two lines were perpendicular, they had opposite reciprocal slopes. I'm going to make that mark in there so that I remember I meant for them to be parallel. And also, if you remember, we talked about in the first unit how to mark parallel lines. These two are parallel to each other. We put those arrows on there to denote that they are parallel to each other. So in summary, slope is rise over run, the change in y over the change in x. Parallel lines have the same slopes, and perpendicular lines have opposite reciprocal slopes.